Hi everyone, in this video we are going to solve a problem based on discrete time Fourier series. So there are two kinds of signal, one is continuous time signal and the other one is discrete time signal. So in this video we are going to solve a problem related to discrete time signal with the help of discrete time Fourier series. So we'll directly move on to the problem. The problem is the signal x of n is a discrete time periodic signal with x of n is equal to 1 for 0 less than or equal to n less than or equal to 4 and 0 for 5 less than or equal to n less than or equal to 6. So this is the given signal. And we need to find fundamental period of y of n is equal to x of n minus x of n minus 1. This is the first question, and the second question is we need to find the Fourier series coefficient of y of n, right? So the given signal is a discrete time signal with periodic representation. That means the given signal has a repeated number of pattern of same signal. So the given signal is a periodic signal. So the signal x of n can be, first let me draw the signal x of n for the given intervals solution. So this is my x-axis. Let us assume this is n, because n denotes the discrete samples, number of discrete samples, right? So the amplitude 1 is for the samples 0, 1, 2, 3 and 4. Similarly, the amplitude 0 is for the samples, for the discrete samples 5 and 6, right? Let me draw this two samples in this representation. So let me start with 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. So 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is my discrete samples, and the corresponding amplitude for these samples are, so for the samples 0, 1, 2, 3, 4. So starting from 0 to 4, the magnitude is 1 or the amplitude is 1, and for 5 and 6 the amplitude or magnitude value is 0. So for 0 it is 1, 1 it is 1, 2 it is 1, for 3 it is 1, and for 4 it is also 1, right? So this is the amplitude for these signals, right? Next, 0 is for the samples 5 and 6. So 0 is marked by a darker dot, right? So this is the given signal, discrete signal x of n. So this is the given discrete signal x of n, where this corresponding signal will repeat the same pattern from the sample number 7, 8 and etc., right? Because the given signal is a periodic signal, so the same amplitude that is from 0 to 6 will again repeat from the sample 7 to the next preceding samples, right? So next, let me, now I have found the value for x of n. Next I need to find the value for x of n minus 1. So x of n minus 1 is nothing but delay, minus. If it is minus, then it is delay. If it is minus 1, then I am going to delay the x of n by 1 unit. If it is x of n minus 2, then I am going to delay this x of n sample or x of n signal by 2 units, right? So the given signal as x of n minus 1. So I am going to write, or I am going to draw the given x of n in 1 unit delay. So the above graph can be drawn as, now it is going to delay by 1 unit, so I am going to just move one sample towards right. So each and every sample will move towards right. So 0th sample will move to first sample. So there will not be any sample in 0th sample, right? There will not be any signal in 0th sample. 0, 1, 2, 3, 4, 5, 6, 7 and 8, right? Now let me shift the signal. So 1 I will have amplitude 1, and for 2, 3, 4 and for 5 I will have 1. Then 6 I will have 0, and in 7th sample I will have 0. Next 8th sample, the next set of values, because this is a periodic signal, so again this same set of signal will repeat from 8th sample onwards, right? So this is my x of n minus 1 signal with 1 unit shift, 1 unit delay, right? So now I need to find the value of y of n, which is x of n minus x of n minus 1. X of n minus 1, right? So already have the value for x of n and x of n minus 1. From this I need to subtract these two values. I need to subtract these two values to get the value of y of n. So I am going to subtract these two values to get the value of y of n. Now look at here. In this x of n minus 1, in x of n I have 1, but for 0th sample in x of n minus 1 I don't have any value, it is 0. So 1 minus 0, its amplitude in this, for x of 1 0th sample I have amplitude 1, but for x of n 0th sample I have amplitude as 0. So 1 minus 0 I will get for 0 I will get 1. 1 minus 0 I will get amplitude 1, right? So next, for let me go to the second sample of x of n, x of n minus 1. Now I am subtracting these two things. Here it is 1, and for x of n minus 1 is also it is 1. So 1 will get cancelled. So I will get 0 for 1. So I will get 0 here, right? Next, comparing x of n second sample with x of n minus 1 second sample. So here it is 1, here it is 1. So 1 will get cancelled. Let me write the amplitude level, so that it is really easy for us to subtract the values, right? So for second sample of x of n, x of minus 1, here it is 1, amplitude is 1, and here it's also 1. So 1 minus 1, the value will be, for second sample, the value will be 0. 1 minus 1, 0. Similarly, for third and fourth, the same amplitude value is having for x of n and x of n minus 1. So the third sample and fourth sample will also be 0. 3 and 4 will be 0, right? This is 1 and this is 0, 0, 0, 0, right? Now I am comparing the fifth sample of x of n, which is 0, with x of n minus 1 fifth sample, which is 1. So 0 minus 1 I will get 0 minus 1 I will get minus 1. So for fifth sample the value is minus 1, right? Next I am comparing the sixth sample. The x of n sixth sample is 0 here, and the value of x of n minus 1 sample is 0 here. So 0 minus 0 I will get 0. So 0 for sixth. The given signal is a periodic signal, so the given samples are from 0 to 6. So the next interval will repeat from the sample 7. So I have adding the 7th sample and 8th sample values as 1 here, right? So if this is x of n, then x of n minus 1 a unit of delay 1 will be added in x of n minus 1. So the 7th sample will move to 8th sample, right? Right, okay. So let me come to this. So 6th sample of x of 0 and x of n minus 1 is 0 here. Next x of 7 is 1 and x of 7 of x minus 1 is 0. So 1 minus 0 I will get 1 for 7th sample. This is 1 for 7th sample. Similarly, etc. up to 8, 9, 10, 8th sample, 9th sample, etc. Right? So this is the representation of y of n for the given periodic signal x of n, right? Now we need to find the fundamental period of y of n. Fundamental period of y of n means we need to calculate the time period of the signal, time period of the given signal x of n. Now let us consider this x of n. Its sample starts from 0, 1, 2, 3, 4, 5, 6 and it's again start at the interval or sample 7. So the fundamental period of the given signal x of n is t is equal to 7. We should take the time period of the first set of signal to the signal when it is repeating again, right? So 0 to 6 is the first set of signal, then it is going to repeat again, the same set of interval is going to repeat at the sample 7 or from the sample 7. So we need to consider this time period also. So the total time period or the fundamental time period of the given signal x of n is 7. So t is equal to 7, right? Or if you calculate the number of samples, you will get 7. 0, 1, 2, 3, 4, 5, 6. So total number of sample is 7, right? Total number of sample is 7, but we need to consider the time period between the first set of signal to the next set of repeating signal first interval, between the first interval, right? So t is equal to 7 here, right? So next, the second question is we need to find the Fourier coefficient representation of y of n. We need to find the Fourier series coefficient representation of y of n. So we know that the formula for continuous time signal, Fourier series for continuous time signal, and Fourier series coefficient representation is given by x of k is equal to 1 by t summation n is equal to 0 to infinity small x of n into e to the power j into k into omega naught n. So this is the formula for Fourier series, discrete time Fourier series, right? Discrete time Fourier series. We are going to find the coefficient of the same, right? So this can be expanded as we know that the value of t for the given signal is 7 and we also know the value for omega or omega naught is equal to 2 pi divided by t, right? So replacing this in the formula we will get 1 by t is the t for the value of t. I am going to replace it 7 summation n is equal to 0 to infinity x of n into e power j into k into omega is replaced by omega 2 pi by t. So 2 pi by t is 7 here into n, right? So this is the Fourier series coefficient of signal y of n, right? So I think you understand with the problem and the Fourier series coefficients. Thank you.